Good morning
Good evening.
and welcome to the first session on circulatory system. A warm welcome to all my dear students of class 10. Today we are going to have a look at the first part of the circulatory system. And in this first part of the circulatory system, we are going to look at the world of what are the different components of what the circulatory system comprises of. As the video truly envisaged very vividly, the different components of the circulatory system, what may seem so very simple, flow of blood, is in reality a very complex community of different particles and corpuscles. These are the very corpuscles that keep our immune system intact. They are the ones which keeps our body in its shape, in its form. It is the only system which rotates throughout our body. So it is known as a connective system. To move with, it is this connective system which connects all the different systems of our body. To begin with, the digestive system. All the end products of digestion, be it the food, the carbohydrates, the amino acids and the fatty acids, which are the end products of digestion, are carried to the required target cells via this connective system. When we breathe in oxygen and we breathe out carbon dioxide. It is this intake and exchange of gases which goes to its target cells via this connective system. Having done all the work, the end product of all our metabolic activities and whatever is not required in our body, the excess water, salts, nitrogenous waste is given out via the excretory organs. But it is this system which takes them to that particular organ. And finally, we have the endocrine system, the hormones, which regulates the way we grow, the way we behave. And these hormones are carried by this connective system, the blood, to all its target cells. Hence, each system requires a vehicle to transport different materials to different parts of the body. And it is the blood and its components that does the very needful. And it is in this energizing the different parts of the body that we grow. Along with the moving component, which is the blood, there are other liquids which are called the synovial fluids in the joints, the aqueous humor in our eyeball. These are the non-movable liquids. So as you look at the principal fluids in our body, which are they? We know of blood for certain. So blood, which moves from the heart and the different blood vessels via arteries, veins and capillaries. We have the tissue fluids, which we have mentioned, the synovial fluid and the aqueous humor in the eye, which are non-movable. And finally, we have the lymph, which is moving in the lymphatic system, which is primarily concerned with defense and immune system. So these are the three main fluids in our body: the blood, the tissue fluid and the lymph. Let's have a look at the characteristics of blood. It is always in circulation, never stationary. The moment blood becomes stationary, it coagulates and forms a clot. So it is necessary that blood is in constant motion. Color. Where it is bright, it is fresh, full of oxygen. So it is known as oxygenated blood. And having used this oxygen by the different parts of our body, it becomes darkened because of presence of carbon dioxide. Volume. Can you take a wild guess how much blood we all carry in our body? So it is nearly 5 to 6 liters of blood. Most of the emergency blood is stored in spleen. Taste. You may have, certainly, sometime when you have a poke, just put a finger in your mouth and taste the blood. It's slightly salty and slightly alkaline. The pH of blood is somewhere between 7.3 to 7.45. Having done the very characteristics of blood, let us now move on to the functions of blood. The first function of blood, as we see, is transport. Transport of the different systems. The digestive system, the respiratory system, the oxygen combines with the hemoglobin component of the blood. Even carbon dioxide. So, both oxygen and carbon dioxide are carried by blood. The nitrogenous waste from the different parts of our body is taken to its excretory system via blood. The endocrine system, which contains hormones. These hormones reach their target or cells via the connective system, which is blood. And finally, it is thermoregulatory in its nature. It maintains the temperature of the different organs of the blood. So here we have the transport system, which connects all the different systems of our body. Along with transport, you will be surprised to know that it also has a very protective function in it. It protects and produces antibodies and antitoxins, which neutralizes and kills the germs. The WBCs are the commandos of our body, which go out on those war fronts. As on today, we have our doctors and nurses on the front line fighting the virus. Similarly, the white blood cells are on the front line of defense to attack any incoming infection. Finally, it also forms clot, so we do not lose blood or hemorrhage to death. Thus, we see that blood has dual functioning, both transport as well as protection. Now let us see what blood is made up of. We call it the composition of blood. If I take a small volume of blood and if I centrifuge it, I notice that there are two very distinctive parts. A straw color liquid, which we call plasma. Alkaline, it contains proteins and fibrinogen. If I remove fibrinogen from the plasma, it is known as serum. A lot of vaccines and antivenoms are stored in the form of serums. The other 55 to 60% of the blood is made up of corpuscles or cellular elements. These are the erythrocytes or the red blood cells, the leukocytes or the white blood cells, and lastly, so very important for our clotting mechanism, the thrombocytes or the platelets. We begin with erythrocytes. The structure, very small, nearly 7 microns, biconcave, disc-like, flat in the center, thick and round at periphery, colorless, spongy body containing a pigment called hemoglobin. Small, so they can pass through the minutest of parts and give out oxygen to different cells of our body. Biconcave, if you notice, it increases the surface area for the absorption of oxygen. So this structure of biconcave makes this oxygen absorbing capacity to its fullest potential. They are produced in the spleen in adults and in the marrow of long bones and breastbones. Totally nearly 2 million in adult. Oxygen is required during our exercise for different parts and metabolic activities of our body. This oxygen is supplied via erythrocytes or the red blood cells. The average life is 120 days. Once they are old and weak, they are destroyed in the spleen, liver and bone marrow, and the iron is returned and the rudiments or the pigments are stored in the liver. Hemoglobin, which is composed of iron, which is hemin, and globin, which is protein. Together we call it hemoglobin. When it combines with oxygen, is known as oxyhemoglobin. When it combines with carbon dioxide, it is known as carboxyhemoglobin. When it combines with carbon monoxide, it becomes a deadly combination, resulting in carbon monoxide poisoning and even leading to death. Sometimes there is an abnormal increase in RBCs, and this phenomena is known as polycythemia. While on the other hand, there is a decrease is known as erythropenia. Let's have a look at the second component, which is the white blood corpuscles or the leukocytes. There is a whole family of leukocytes comprising of different shapes and sizes to perform the different functions. They have a nucleus, hemoglobin is absent, and mostly amoeboidal. They can take any shape and size. So they can squeeze out and squeeze in to the different pores and thus go to where the infection is. This process of squeezing in and out of the capillaries is known as diapedesis. I repeat, diapedesis. Here is a family of white blood cells. We have the granulocytes and the agranulocytes. Among the granulocytes, we have those white blood cells which contain granules and the nucleus is in lobes. They are neutrophils with 2 or 3 lobes. The function is to engulf or swallow the bacteria. The process of swallowing bacteria is known as phagocytosis. Thus, it is very, very important for a defense mechanism. Next is eosinophils. Again, it produces antitoxins and fights the different allergies that we come across. Last but not the least, it is basophils. The basophils produces histamine, which are chemicals which dilates blood vessels, making walls leaky and involved in producing some allergies to foreign materials in body. cytoplasm is stained by eosinophils. So we have these three, and if you look at them, neutrophils, which is a component of white blood cells which accepts a neutral dye, eosinophils which accepts eosin, and basophils which is stained with eosin, the basic dye. We move on to the second category, which is agranulocytes. Among the agranulocytes, they have a single large nucleus, unlike the granulocytes, where the nucleus was in lobes. Here it is single large nucleus. That's the main difference. Along with this main difference, the first one is lymphocytes, and they are concerned with producing antibodies. And lastly, they are monocytes. The monocytes are the commandos of our body. So they move in via diaperesis and they do phagocytosis, which engulfs them. Hence, they wander into tissues, ingest germs, and clean up the damaged cells. Hats off to these warriors of our blood system, because of which we are all alive and ticking. Thus we come to the end of our first module on composition of blood. I hope you have a thorough knowledge looking at this video, and as we come to the end of this, I will send you the PPT, and then we can zoom up on a class and take care of any doubts or the more explanation that you require. So till then, keep smiling and keep enjoying composition of blood. Thank you.